Welcome to the Alternative Fuels lecture. You'll probably recognize this from Back to the Future, the DeLorean that was fusion powered. Okay, think about why we might want a fusion powered DeLorean. Take a couple of minutes, and we'll do this exercise in class as well. But this will set you up and get you thinking about the whole point of this lecture. And list why we should care about alternative fuels. Everything you could think of about why we should care about alternative fuels. Stop the video now and then start it again in a minute actually after you've taken as much time as you like to try to answer this question. Okay, you're back. All right. Well, go through what you came up with as we go through this lecture. But I'll start by saying that New Zealand is a net importer of energy in the form of petroleum products, mostly. All right, we've got coal reserves, we've got a lot of hydroelectric power, some power generation from thermal, geothermal stations, but none of the fuel that we put into our cars in terms of petrol or diesel is produced here in New Zealand, and so we import the energy that we use for petroleum products generally from overseas. All right, so here is a good reason to care about alternative energies. All right, this is from the United States. 2008, oil prices reached a high of $145 per barrel. Okay, so now we're around about $110 a barrel. These are per gallon prices in the States. These prices are absolutely brutal for people who were used to paying a couple of dollars a gallon. This was when things were going on in the Gulf. And in Iraq, and there was instability, and with the just slightly before the Arab Spring started happening. When I left the States in 2000, I could buy a gallon of gas for 87 cents, fill up my car for less than $15. But now we've seen the end of that type of cheap oil. It's going to go up. It's still cheap, really, in terms of what you get for it. But we are only going to see higher and higher prices in terms of fuel. All right, and world population. Okay, this is, as you have seen before. We've seen this. You've seen this graph before in other classes, and in this one, fisheries management. We are probably not going to hit 10 billion according to all the projections, but you have got to understand that the population is going up, and we've still got another billion and a half to go before we start to really hit the peak. And all of these people are going to want lifestyle standards of living like ours. And why wouldn't they? Okay, it's fair enough. We've been lucky to be born into an area where we have a reasonable standard of living and not making less than a dollar a day, as a lot of people are. But the other problem with this increasing population is that we are running into something called peak oil. Now, there are some videos listed, some links to videos on YouTube here and here, which we'll pay a little more attention to in class. They can sum it up better than I can on this video. But you've got this first one is called Part 1 of Peak Oil, The Truth and Lies. It's well explained but fairly biased, so you have to take it with a grain of salt, as you would with really any non-peer-reviewed source. And the second one, a melodramatic American TV snippet about terrorists or some other supply choke turning into anarchy with fuel shortages. animated short showing a quick history of global oil production levels here, and then this one quite varied with quite a few people contributing to the video. And then these ones are also both very good. Now, once you start looking at peak oil on YouTube and other sources, there are you can just go down the track for hours, if you want it. If you go from one video to the next, and there are lots of different opinions and various degrees of what I would call scientific accuracy in them. But very interesting videos, and so you may have already covered this in another lecture, but it was predicted in 1956 by M.K. Hubbert the maximum amount of production would occur between 1969 and 1971. At that point in 56, the U.S. was the leading producer of petroleum products in crude oil in the world. Hubbert was a geoscientist who worked with Shell Research Labs down in Houston, Texas. And he predicted that for any given field, any oil field, or the planet as a whole, that, and this was after observing lots of these fields be drilled, ramp up in production, and then peter out, said that this was actually a relationship that always was going to follow. That petroleum production would resemble a bell curve, and so he made the prediction that U.S. production would peak in these years, 1969 to 71. And then he put these predictions out, and he was ridiculed. He was widely criticized until between I think about 1970. U.S. domestic oil production did peak, and so the global production of oil fell. If you follow the trend, now the production of oil has fallen from a high point in 2005, and then has rebounded. And 2011 figures show slightly higher levels of production than in 2005. Now this is worldwide. Since the 70s, the U.S. production has gone down and down and down. So there's quite active debate as to how to measure peak oil and which types of liquid fuels to include. But most of the remaining oil is from unconventional sources, so not just crude oil. It's things like shale oil and natural gas that can be fracked out of previously unobtainable substrates. And rough estimates indicate that out of an available 2 trillion barrels of oil, about half has already been used. And we've only been using petroleum to a great degree for about 120 years. So in 120 years, we've used half of the oil available on the planet. Okay, that took millions and millions of years to produce. Now, in order to understand how this energy is mainly utilized or mainly turned into usable forms for human beings, we need to understand two components, two mechanical devices. We need to understand the turbine and the internal combustion engine. And so you can watch these videos, but we'll be going over these in class as well. So these are very good animations of how turbines and internal combustion engines work. Okay. So let's actually look at some of the alternative fuels. Coal. All right, this is still a fossil fuel, but it is an alternative to gasoline and petroleum products. So it was hard to decide on creating this lecture whether to include petroleum products, fossil fuels in as alternative fuels. But I thought that since most of the world's energy, especially for transport, is comes in the source of petroleum products or natural gas. I thought that I would include coal, as standard as it is, as a alternative fuel. So really we're talking about alternatives to gasoline and diesel. All right, so generally in power plants worldwide, this is the first choice for fuel. All right, so there'd be very little steel or cement production in it without it. So the building that you're sitting in right now would probably not exist without coal-fired electricity. And it's very abundant, found in over 70 countries. So about that would make it about a third of countries would have coal, and there's a lot of it. Okay, and so we have enough at the current rate that we're using energy to supply the world for roughly 200 years. All right, so it's cheap. You can dig it out of the ground, and you get a lot of energy return for how much you put into it for digging it out of the ground. It's very predictable. It's stable. It's easy to transport. It doesn't explode into flames when you're transporting it. You don't have to pressurize it. And it's very cheap to build a power plant. You just simply have to have a way to keep it flowing into a burning area that heats water, and you can turn a turbine with the resulting steam. And if you haven't watched the turbine or internal combustion engine videos, I think this is probably a good point to stop the video and go back and watch those. Familiarize yourself with a turbine. So it's very cheap to build power plants, and these things are coming online, especially in China and India and other places, very quickly. 70% of the United States power comes from coal. All right, and we're digging it out of the South Island at a high rate and shipping it overseas. So whether we, even though we are lucky in that we have quite a lot of renewable energy sources for New Zealand's energy requirements, we're certainly complicit in any global warming that comes from coal burning and the other issues with it by digging it up and sending it overseas. Okay, just like when you buy some cheap plastic product that comes from somewhere else with lower standards, we're just exporting our environmental problems to another country. So, coal, the biggest source of carbon dioxide buildup in the atmosphere, can be attributed to coal burning. The mining conditions, a couple of thousand workers at least die every year in coal mining. We had the Pike River mining blast a couple of years ago, and so that was maybe unacceptable to some people, to others maybe not, but the mining conditions are very dangerous for coal. There are environmental effects from open cast mining as well as tunneling, and if you've followed the debate about the Denniston Plateau in the South Island, you'll be aware of what sort of environmental effects there are. And tunneling, we've seen sinkholes in Waihee Beach, so these things are local effects as well as other places. But if you tunnel enough of the ground away underneath buildings and the like, eventually, if they collapse, then a hole opens up at the surface that where the topsoil and the overlying bedrock collapses into those holes, and you get sinkholes. Let's say other harmful byproducts when you burn coal: sulfur dioxide, carbon monoxide. So sulfur dioxide is quite a it's the same thing that comes out of volcanoes, but it's not a great thing for humans to breathe. Carbon monoxide, same thing. Arsenic Okay, so these things they come out in the smoke. Arsenic, selenium, those are both toxic heavy metals, depending on their concentration. But these things are spewed out, I suppose. They're emitted in the burning of the coal, and so then they are distributed quite evenly by the atmosphere, carrying the particles from the coal burning, and then dropping them with rain, or as they drop out of the sky, just through being heavier than air. And so you get a buildup of these particles, not in such great concentrations that you would probably be able to measure it at a dangerous level in any particular soil or water. But what you do find is that they build up through the food chain. Now, you've probably heard that that a lot of the top predators have high levels of mercury in their tissue, like tuna and the like. 200 years ago, before coal was burnt great as widely as it is, there would have been no issue with mercury buildup in these top predators. But now, because of coal being used as one of the main sources for electricity, we do have that issue. Okay, we're going to stop the video here, and we'll go pick up again in alternative energy sources, alternative fuels too. Thank you.